The National Electrical Code, specifically Article 351, addresses rigid metal conduit and intermediate metal conduit. Section 351.4 mandates rigid or intermediate metal conduit for protecting cables and conductors in hazardous, classified locations. However, this section typically does not extend to office spaces within an industrial building, provided they are not situated within the industrial plant area itself. Article 358 of the National Electrical Code pertains to flexible metal conduit. Section 358.10 stipulates that flexible metal conduit must be installed in accordance with Article 350 concerning rigid metal conduit and intermediate metal conduit, or as permitted by Section 358.12. Section 358.12 outlines acceptable uses for flexible metal conduit, including dry, moist, or wet locations, specifically for pendants, when supported according to Section 410.30c, inaccessible attics without insulation, within the joist space of unfinished basements, and in raceways. Notably, neither Article 350 nor Article 358 explicitly requires the use of EMT or flexible metal conduit within office walls in industrial applications. Industry standards also play a role. NFPA 70, the National Electrical Code, which was referenced earlier, serves as the primary standard for electrical installations throughout the United States. It encompasses all facets of electrical wiring, including conduit requirements. NFPA 79, titled Electrical Standard for Industrial Machinery, addresses electrical requirements specific to industrial machinery. It provides guidance on conduit usage, but it does not mandate the use of EMT or flexible metal conduit in office walls. OSHA regulations, specifically 29 Code of Federal Regulations Part 1910, establish minimum safety standards for electrical installations in workplaces. However, these regulations do not specify conduit requirements for office walls and industrial applications. Based on the information presented, no singular standard demands the installation of EMT or flexible metal conduit in office walls for industrial applications. It is always recommended to consult with a local authority having jurisdiction to ascertain any local regulations or requirements that may be applicable. When considering electrical installations, understanding the specific articles within the National Electrical Code is paramount. For example, Article 300 provides general requirements for wiring methods and materials. Article 310 addresses conductors for general wiring, including ampacity and insulation requirements. Article 314 covers outlet boxes, device boxes, pull boxes, and junction boxes. Article 320 details armored cable type AC. Article 330 concerns metal-clad cable type MC. Article 334 relates to non-metallic sheet cable types NM, NMC, and NMS. Article 340 covers underground feeder and branch circuit cable type UF. Article 344 discusses rigid metal conduit. Article 350 pertains to flexible metal conduit. Article 352 addresses rigid polyvinyl chloride conduit type PVC. Article 356 covers liquid-type flexible non-metallic conduit type LFNC. Article 358 relates to electrical metallic tubing type EMT. Article 360 concerns flexible metallic tubing type FMT. Article 362 discusses electrical non-metallic tubing type ENT. Article 366 covers auxiliary gutters. Article 368 pertains to busways. Article 370 addresses cable trays. Article 374 covers cable bus. Article 376 relates to metal wireways. Article 378 concerns non-metallic wireways. Article 380 discusses multi-outlet assembly. Article 382 pertains to non-metallic extensions. Article 384 addresses underfloor raceways. Article 386 covers surface metal raceways. Article 388 relates to surface non-metallic raceways. Article 390 concerns undercarpet cable. It's important to note that the National Electrical Code is updated every 3 years, so it is crucial to consult the latest edition for the most current requirements. Furthermore, local jurisdictions may have amendments or additional requirements that supersede the National Electrical Code. When working with electrical systems, safety is of utmost importance. Always energize circuits before working on them, and use appropriate personal protective equipment, such as gloves and eye protection. Follow all applicable electrical codes and standards, and consult with a qualified electrician if you have any questions or concerns. Understanding conductor ampacity is also crucial. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. National Electrical Code Table 310.15b16 provides ampacity ratings for various conductor types and sizes, based on insulation type and temperature rating. The ampacity of a conductor is affected by several factors, including the ambient temperature, the number of conductors in a raceway or cable, and the presence of other heat-generating equipment. When conductors are installed in conditions where the ambient temperature is higher than 30 degrees Celsius or the number of conductors in a raceway or cable exceeds 3, the ampacity must be derated according to National Electrical Code Table 310.15b3 and 310.15b2. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The size of the overcurrent protection device must be coordinated with the ampacity of the conductor it protects. National Electrical Code Section 240.4 specifies the requirements for overcurrent protection of conductors. Grounding and bonding are also critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices and prevent electrical shock. Bonding connects all metal parts of an electrical system together to create an equipotential plane, which minimizes the risk of electric shock. National Electrical Code Article 250 provides detailed requirements for grounding and bonding. Understanding voltage drop is also essential for ensuring proper operation of electrical equipment. Voltage drop is the decrease in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to malfunction or fail. National Electrical Code Section 210.19a on FBN number 4 and 215.2a on FBN number 2 recommends that the voltage drop on branch circuits should not exceed 3% and the voltage drop on feeders should not exceed 5%. Calculating voltage drop requires knowing the conductor size, length, and current, as well as the conductor's resistance and reactance. Several online voltage drop calculators are available to assist with these calculations. In industrial settings, special considerations may be necessary for electrical installation. For example, hazardous locations, such as areas where flammable gases or vapors are present, require explosion-proof equipment and wiring methods. National Electrical Code Articles 500 through 516 provide detailed requirements for hazardous locations. Also, industrial machinery often requires dedicated circuits and control systems. NFPA 729 Electrical Standard for Industrial Machinery provides guidance on the electrical requirements for industrial machinery. When designing and installing electrical systems, it is essential to consider future needs and expansion. Providing spare capacity in raceways and panels can make it easier to add new circuits and equipment in the future. Also, using modular equipment and wiring methods can simplify modifications and upgrades. Proper documentation is crucial for maintaining electrical systems. Accurate as-built drawings and wiring diagrams can help with troubleshooting and repairs. Also, maintaining a record of all electrical work performed, including inspections and testing, can help to ensure the safety and reliability of the system. Regular inspections and testing are essential for identifying and correcting potential problems before they cause equipment failure or safety hazards. Visual inspections can identify damaged or deteriorated components, while electrical testing can verify the integrity of circuits and equipment. National Electrical Testing Association standards provide guidance on electrical testing procedures. When performing electrical work, it is essential to follow lockout/tagout procedures to ensure that circuits are de-energized before work begins. Lockout/tagout procedures involve disconnecting the power source and placing a lock and tag on the disconnect switch to prevent accidental re-energization. OSHA Standard 29 Code of Federal Regulations Part 1910.147 provides detailed requirements for lockout/tagout procedures. Surge protection is another important consideration for electrical systems, especially in areas prone to lightning strikes or power surges. Surge protective devices are designed to protect sensitive electronic equipment from voltage spikes. National Electrical Code Article 280 provides requirements for surge protection. Power quality is also an important consideration for electrical systems. Power quality problems such as voltage sags, swells, and harmonics can cause equipment to malfunction or fail. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Power factor correction can improve the efficiency of electrical systems. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy consumption and reduced system capacity. Power factor correction capacitors can be used to improve the power factor. Energy efficiency is an increasingly important consideration for electrical systems. Using energy-efficient lighting, motors, and other equipment can significantly reduce energy consumption and operating costs. Also, implementing energy management strategies such as lighting controls and demand response programs can further improve energy efficiency. Renewable energy sources, such as solar and wind, can be integrated into electrical systems to reduce reliance on fossil fuels. National Electrical Code Article 690 provides requirements for solar photovoltaic systems. Battery backup systems can provide backup power in the event of a power outage. Battery backup systems are commonly used for critical equipment, such as emergency lighting and life support systems. Uninterruptible power supplies provide continuous power to sensitive electronic equipment, even during short power interruptions. Uninterruptible power supplies are commonly used for computers, servers, and other critical equipment. Harmonic mitigation techniques can reduce the negative effects of harmonics on electrical systems. Harmonics are unwanted frequencies that can distort the voltage and current waveforms. Harmonic filters and other harmonic mitigation techniques can be used to reduce harmonic distortion. Arc flash protection is an important safety consideration for electrical systems. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or fault in the system. Arc flash hazard analysis can be used to determine the potential arc flash hazards and to select appropriate personal protective equipment. National Electrical Code Article 110.16 and NFPA 70E provide requirements for arc flash protection. Electrical safety training is essential for all personnel who work on or near electrical equipment. Electrical safety training should cover topics such as electrical hazards, lockout/tagout procedures, and personal protective equipment. OSHA provides resources and guidance on electrical safety training. Ground fault circuit interrupters are designed to protect people from electric shock. Ground fault circuit interrupters trip a circuit when they detect a small amount of current leaking to ground. National Electrical Code Section 210.8 requires ground fault circuit interrupter protection in certain locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters are designed to protect against fires caused by arc faults. Arc fault circuit interrupters trip a circuit when they detect an arc fault, which is a dangerous electrical condition that can cause a fire. National Electrical Code Section 210.12 requires arc fault circuit interrupter protection in dwelling units. Regular maintenance of electrical equipment is essential for ensuring its safety and reliability. Regular maintenance should include visual inspections, cleaning, and testing. National Electrical Testing Association standards provide guidance on electrical maintenance procedures. When troubleshooting electrical problems, it is important to follow a systematic approach. Start by gathering information about the problem, then use a multimeter or other test equipment to diagnose the cause of the problem. Once the problem is identified, take steps to repair or replace the faulty equipment. Proper labeling of electrical equipment is essential for safety and efficiency. All electrical equipment should be clearly labeled with its voltage, amperage, and other important information. National Electrical Code Section 110.21 provides requirements for labeling of electrical equipment. When working with electrical systems, it is important to be aware of the potential hazards and to take appropriate safety precautions. Electrical work should only be performed by qualified personnel who have been properly trained. By following these guidelines, you can help to ensure the safety and reliability of electrical systems. Always consult with a qualified electrical engineer or electrician for specific design and installation requirements. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Understanding the National Electrical Code and other relevant standards is crucial for ensuring the safe and compliant installation of electrical systems. Remember to stay updated on the latest code revisions and local amendments.